Today, we're going to dive into one of the most common and honestly surprisingly dangerous ways software can betray our trust. It's a weakness that leads to what you could call an accidental overshare of secrets. And the wild part is, you've probably seen it happen without even realizing it. Let's kick things off with a pretty jaw-dropping, real-world example.
Okay, take a look at this. This is a real error message that an application spit out. Now, at first glance, it just looks like a bunch of technical jargon, right? But look closer. Right there, in plain text for absolutely anyone to see, the password is N1NG4. This is basically the digital version of accidentally writing your ATM PIN on the back of your debit card.
That horrifying little error message is the perfect example of what we're talking about today. See, it's not just some random bug. It's a very specific kind of vulnerability. And the accidental overshare is a great way to think about it. So what happened there? The software, in its attempt to be helpful by flagging an error, accidentally spilled a massive secret. It was just trying to say, hey, I can't connect to the database. But in the process, it handed an attacker the exact username and password they'd need to waltz right in.
Now, a screw-up this common actually has an official name in the cybersecurity world. It's cataloged in what's called the Common Weakness Enumeration, or CWE for short, as weakness number 201. So let's break down what that really means.
So the formal definition here is, well, it's a bit of a mouthful. But the core idea behind it is actually super simple. The software sends out some data, but a secret gets mixed in and sent along for the ride when it absolutely shouldn't have been. You know, here's an easy way to think about it. Imagine your mail carrier is delivering a package to your neighbor, but when they do, they also accidentally show your neighbor a private, sealed letter that was meant only for you. The mail carrier is the software. The package is the data it's supposed to send, and your private letter, well, that's the secret that just got exposed.
So what kind of secrets are we actually talking about here? Well, it can be the obvious stuff, usernames and passwords, but it could also be your private messages or even internal system details like file paths. And those are like a blueprint that an attacker can use to plan a much bigger break-in. And of course, it could be your personally identifiable information, your name, address, all that private data.
So how does this actually play out in the real world? It's usually a pretty simple chain of events that can turn what should be a minor hiccup into a major security disaster.
It often starts with you, just using an app like normal. Then, something goes wrong in the background. Maybe a database is down or a file is missing. The system, trying to be helpful, generates this really detailed error message for its own developers to use for debugging. But, and this is the critical mistake, instead of showing you a generic "oops" page, it sends that detailed internal message straight to your screen, secrets and all. The single biggest consequence of this weakness is a total loss of confidentiality. Information that was meant to be private is suddenly out in the open. It allows anyone to read, copy, and use data they should never, ever have access to. This is exactly how accounts get hijacked and how sensitive company data ends up for sale on the dark web.
Okay, so the problem is clear and it is serious. But the good news is it's also entirely preventable. So let's talk about how we can build a much stronger defense against these accidental overshares.
The most important thing to get is that you can't just patch this kind of problem at the end. A real, robust defense has to be part of the entire process, from the very first blueprint all the way to the final launch and beyond. It all starts way back in the design phase. Software architects should build digital walls. It's called compartmentalization, so that sensitive data is locked away and can't just leak out. They also need to follow the principle of least privilege. It sounds fancy, but it just means a piece of code should only have access to the absolute bare minimum information it needs to do its job, nothing more. Next up, during the actual coding. This is where developers have to be really vigilant. The rule is simple. Double-check everything the application sends out to a user. If the user doesn't absolutely need to see a piece of information to use the app, then it needs to be stripped out before it ever gets sent. And finally, you've got the last line of defense, how the system is configured once it goes live. This is where you make sure that if some totally unexpected error does happen, the system is set up to show a safe generic message like, "An error has occurred," instead of just spilling all its internal secrets.
Okay, so we've looked at the problem and the solution from a pretty technical angle. But why does this specific weakness matter to you as someone who uses apps and websites every single day?
Well, to put it in context, our accidental overshare, CWE-201, is actually just one specific type of a much broader weakness, CWE-200.
Think of it like this. CWE-200 is the big general problem of exposing sensitive info. Our weakness today, 201, is just one very common way that happens, by accidentally mixing secrets into the data that gets sent out.
Ultimately, the security of your personal data really relies on the developers of your favorite apps and websites knowing about this exact problem and actively working to prevent it. I mean, every time you log in, send a message, or even just see an error page, you're trusting that they've done their job right to prevent an accidental overshare of your information.
And that leaves us with a final, pretty thought-provoking question. The next time an app or a website gives you some weird, technical-looking error message, maybe take a closer look. Because this isn't some theoretical problem. It happens all the time. What secrets are your favorite apps accidentally sharing?